Before Earth, before Mars, and before the rings of Saturn, there was Jupiter. In this episode of Infinity Beyond, we travel 4.6 billion years into the past to uncover the violent, chaotic birth of Jupiter, and how this one planet's formation may have determined everything from the existence of Earth to the placement of asteroids. Jupiter is thought to be the first planet to form after the Sun ignited. Within just a few million years of the solar system's birth, Jupiter began accumulating mass. According to the widely accepted core accretion model, Jupiter started as a solid core made of ice and rock, around 10 to 20 times the mass of Earth. Once this core reached critical mass, it began pulling in the hydrogen and helium gas that remained in the solar nebula, the giant cloud of dust and gas left over from the Sun's formation. This process happened fast, within 1 to 10 million years. If it had taken any longer, the gas would have dispersed, and Jupiter might never have grown to its present size. But why is this important? Because Jupiter's formation didn't just create a planet. It triggered a cascade of gravitational effects that shaped the rest of the solar system, clearing the neighborhood. As Jupiter grew, its powerful gravity began sweeping up or scattering nearby debris. It prevented other large planets from forming between it and the Sun, which is why the asteroid belt never coalesced into a planet. Jupiter also began flinging leftover planetesimals outward, helping to form the Kuiper belt and seeding the Oort cloud, the Grand Tack hypothesis. One fascinating theory about Jupiter's early life is called the Grand Tack hypothesis. According to this idea, Jupiter initially migrated inward, perhaps as close as 1.5 AU from the Sun, near the current orbit of Mars. But before it could become a solar system wrecker, Saturn formed, and the two giants entered a gravitational resonance. Their mutual interaction caused them to tack, like a sailboat, and reverse course, migrating outward to their current positions. This inward-outward motion would have had massive consequences. It explains why Mars is smaller than expected. It explains the mixed composition of the asteroid belt, dry and icy bodies. It may have helped deliver water and organics to the early Earth. In short, Jupiter may have helped set the stage for life by both shaping planetary orbits and delivering essential ingredients, organic molecules, and delivery to Earth. As Jupiter scattered icy bodies inward, many of them may have carried carbon compounds, amino acids, and even water. These could have bombarded early Earth, delivering the raw materials for life. Without Jupiter's early gravitational chaos, Earth might have remained dry or never formed at all. Was Jupiter always alone? Recent studies suggest Jupiter may have once had a planetary sibling, a second gas giant that was later ejected from the solar system. This would explain some of the orbital anomalies seen in the outer planets. If true, it means the early solar system was even more violent and dynamic than previously imagined, a place of planetary billiards where only the strongest survived. What Jupiter tells us about other worlds. Studying how Jupiter formed helps us understand exoplanetary systems. Many solar systems discovered so far contain hot Jupiters, gas giants that orbit extremely close to their stars. These worlds likely migrated inward, possibly disrupting the development of rocky planets. Our Jupiter, however, stayed far enough out to allow Earth to form and evolve in peace. Some astronomers believe that a stable, distant gas giant may be a key requirement for habitability, shielding inner planets from comets and providing gravitational structure. Probing the past. NASA's Juno mission continues to gather clues about Jupiter's internal structure and gravity field. Its findings support the diluted core theory, where heavy elements are mixed deep into Jupiter's interior, possibly a result of a giant impact in its youth. Future missions, combined with simulations and lab experiments, may finally reveal exactly how and when Jupiter was born, and whether other systems follow similar patterns. For now, One thing is clear. Without Jupiter, the solar system would be a very different and possibly lifeless place. In the next episode of Infinity Beyond, we'll explore how scientists study the storms of Jupiter, including the technologies used to see through clouds, measure wind speeds, and track lightning on a planet hundreds of millions of kilometers away.